Yours? No?
Thank you.
Huh? And let's see, here's your presentation. You're
Thank you.
welcome.
So, thank you. I will go through an application of URMSM in context of systems engineering. I will use the same colors and model kinds as in the introduction. And the content of this test case is adapted to fit the presentation, which means that the information showed could in reality be much wider and have many more connections, but that wouldn't be very good to show in its case because it was probably lead to confusion at the first stage. So some of the slides are somehow simplified to be able to convey the message. I hope you can have respect for that, and that means that some things might be a bit different maybe than you're used to. And in that case, I'm happy to take a discussion on that and why it looks like it looks for the test case sake. Now, first then, the scope. It's from a systems engineering background, and it's concerned about how to move across IT tools, which is of a very hot concern in engineering as such. And when I'm talking about engineering now, in contrast to what we heard earlier about maintenance inside a manufacturing, we're actually then in a very early phase or stage of a product development, where we sometimes don't even have the things we think we want. We just thought about them. And in the blue line then, and that doesn't mean that there are no similarities, because in context of the standard, we think that that's quite to some degree similar from an information point of view. So what an IT tool is for an engineer is probably very similar to what a production tool is in the tool chain. And that's why the comparison is relevant. It's on a different abstraction level, yet it's using the same systematic approach. So on the top level, then we would have unified reference model smart manufacturing model type, where we talk about a enterprise function. In this case, then it would be engineering. In engineering, there is responsibilities of processes which we need to align, processes which can cross-cut each other. We'll come into the details of that later. But that actually means that if processes are cutting across each other, we need to have a language so that we can distinguish what's yours and what's mine and what's ours. And we need to be able to resolve that to decide whether we need new terms or not. And once we've established that, we could then start to do the smart manufacturing implementation model level, which then is deciding the rules. So given that we agree in the green layer, what do we actually need in the yellow layer? And that might answer, from my point of view, the earlier question where the concept resides. And I think that's a matter of a definition of what we mean by concept. So I'm not sure the first questioner, had the same term in mind when we said concept. Which is a very good example then. But at the end, of course, we need that into a smart manufacturing system. So following this slide, I will start with a unified reference model for smart manufacturing, top left, which then the business function would be engineering, right? There are other functions. Manufacturing could be one, procurement could be one, aftermarket could be one, dependent on how your organization has divided its resources, right? So there could be more or few, and sometimes they will be combined, and another organization chooses to have separate, right? But that would be something we could treat as a dimension, and there's resources allocated to the dimension, which then are covering, in this case, a set of product, method, tool, and information process owners, which are then responsible for a set of activities which must happen in order to know that the product is properly defined. Will this product be possible to release for production? Are the drawing and codes and so forth, are they releasable, right? And in this case, I've chosen to have 4 different aspects, like a product documentation, which then needs to exist so that you properly can long time store information, which is a value. I've chosen a requirements handling process, which is putting expectations on the product so that you know what are the product as a whole or as parts supposed to be doing. There's a question of configuration management. What parts do we have and how do they relate to each other? And there's a question of system safety, assessing that it's good enough to be released for some point of view. And of course, there are several more processes, but for the example's sake, I've just chosen 4. Now, if we treat this as a dimension and aspect, it needs, according to the standard, that the aspects are aligned. They are dependent upon each other and they have relationships, normally over a set of concepts. So let's look into the layer of concepts then and just see what happens. So if I would go from the left side and see also we have product documentation. So I need an activity called long time storage. That needs to happen. Somebody needs to do that. We need to store something. And whatever we store is probably dependent on the product structure object. And that depends on how the product is divided, of course, but some things need to be stored, other might not. They can be during work, but somehow we need to store it. And then we have requirements handling, in this case, responsible for 2 different activities or processes, or rather activities, in this case, like defining requirements or defining functions. Defining a function is then dependent upon the product structure object also, because that means that it needs to be a function somewhere. Otherwise, it's difficult to put a functional requirement on that, right? And out from the definition of a function, it's also dependent on requirements as a concept. It's very difficult to define an expectation if I can't put a requirement. The requirement is defined by the process of define requirements, which also parts of requirements handling, right? So now I have a requirement, which means that I can define the function, but I can also long time store things if there are requirements related to the product structure objects, which then relates to the product breakdown structure, which is the larger thing of philosophy of how we've broken down the product, which in turn is then connected to the process of configuration management, which decides how do we keep track of our stuff in the product, right? And then, of course, we have system safety, which could be treated as a standard for software, for example, ISO 26262, which stipulates safety analysis, which then requires some kind of function to be defined. Otherwise, there's nothing to analyze. Right. So what we see then is that the green concepts are shared over the blue aspects. So there are dependencies. If I change parts of one process responsibility, I might affect another one. If I take away the requirement, safety might not be so happy anymore, and configuration management for documentation might be happy either. If I take away the product structure, none of them would probably be happy because we don't have any product configuration and we don't know basically how the product is divided and so forth. So there are heavy dependencies and these concepts need to be resolved. And basically, there need to be some kind of alignment and decision process for saying who's deciding over what green object and what green object do we actually have, so that we know that we have the proper things. Once we've aligned that and made sure that there is a very clear distinction between what you have and what I have and how we have it together, we can start to set rules on things, saying, okay, so if I had this one, we must have one of those. Yes, most likely. And what's also interesting is that some objects are interesting to have on the green layer, but might not actually exist in the yellow layer at all. And I'm taking the requirements as an example, very vital here to be able to express that we need requirements to get the processes aligned. Yes. Does that mean that I have a generic object of a requirement inside some information? Not necessarily. Why? Yes, because practically to work with things in engineering, I probably need subtypes of requirement. The requirement itself is never visible. The requirement is only of interest to express a need for coordination. I have a functional requirement. I might have a system requirement. I have a component requirement. They're all specializations of a requirement. They're needed in the information model as specializations, not as the higher conceptual object. The higher conceptual object of requirements is of interest to align processes, not of interest to actually implement in a tool. There will be many requirements, but nobody might be interested in all requirements at the same time, because they will always be divided into a structure where the requirement is relevant and then is documented in that relevant context. But the requirement as a requirement isn't existing. It is always existing as information and its subclasses. So the difference between organizing processes so that we know how to share responsibility and working with the information. And this is exactly where URMSM is helping us, because I've been in lots of cases where we can't differentiate between the green and the yellow layer, or even worse, the green and the purple layer. And eventually that causes confusion, because we are not aligned on the green layer and we run in different directions in the yellow or the purple layer. And we can run for quite a while sometimes before we discover that we actually haven't resolved the green layer in a proper way. So we will be running in the wrong direction, and we will be doing things multiple times until we enter the green layer and actually resolve the question properly. Then we can start to divide again into yellow. So what we see then is that I probably have for long time storage, it's dependent on a function, but I have a functional specification as the information object that needs to be stored in a tool, right? I need a functional requirement to define the function, and safety analysis eventually ends up with safety goals, which are important for the safety process, but there are no safety goals in our specifications. There are only functional requirements, because once the safety goal is discovered, it's actually taking the shape of a functional requirement. So for long time storage, it's a functional requirement or part of a safety documentation as a safety goal, right? So it has two phases dependent on what I'm after, dependent on what I choose to long time store. But the specification for the function is one thing, and the safety argumentation is another thing. And they're not the same, but they're actually instantiated twice. So we need the same information at two places. And that's also where we then decide or need the rules for providing information so that the concepts are still true. And that's an important thing. Putting the details of the rules is done in the yellow layer. We do not put the rules in the green layer, because then we're over-specifying the things. Okay. Rules are positioned in the yellow layer so that we then can instantiate them in the proper tool. To the left side, I have an example of an engineering IT setup. For example, we would have a product documentation tool, we have a systems engineering tool, and we have a requirements tool. And following the black triangles, we could see that the product documentation tool is then carrying the function X specification, which is an instantiation of the functional specification. And here's a trick then, in the URMSM. This is an instantiation, which means that the yellow thing has an instantiation. And if you see, all yellow things have an instantiation. And that's the trick. The yellow ones are classes which have instantiations. The green ones can be superclasses if you want.
Then you have a Volvo.
Makes sense. Good reflection. And that also enables you to sort the things out. Where it's instantiated in the tool is where it's mastered. Right? Doesn't mean that other tools don't need the information. Like how I choose to do the product setup is one thing, and how I divide the thing, but I need to reference a certain function. Otherwise, I can't reference the requirements from the requirements tool to the proper function, and I can't document it as a specification in a third tool. And there's a very high dependency. And if I start to create rules in the purple layer, which I have seen happening through APIs, you will eventually risk of taking a real big step into a mess. Because one, you don't know what you're instantiating where, and you don't know if you have the proper rules for it. So eventually somebody else would like to master it. And that might not be the only problem. There can be several other problems, like redundancy of information, or how do you know that that's the master, or I'm being the master actually, because you haven't decided that on the rule level, and you haven't decided the proper origin on the conceptual level, and who's responsible for the existence of the phenomena at all. And that's often, from my point of view, where you get into the discussion that, oh, we need this little prefix. We're talking about software configuration or hardware configuration, or it's a software requirement and it's a hardware requirement, or it's another kind of requirement. That's most often where we need to share our responsibilities on a higher level. But the interesting thing in this case, from us point of view, was that it was totally possible to follow the URMSM. It made sense. It clarified a whole set of process responsibilities, and also enables shared information, because suddenly you can start to talk about, is this item mine or yours, or how would you like it to be? What do you need, and what do I need, and what do we need? It can be shown in the same manner. Now, these are all pictures taken from a tool that's kind of special built for this kind of work. So you can filter smooth and you can take things away and so forth. But as was already mentioned, right, and which I think is really strong in the test case, is that this same example could then very well be built in another tool. In this case it's exemplified by Protégé, which is an open source tool afforded by Stanford. And I'm not saying that's the only tool or the best tool, but important for us was to show that you don't need a specialized tool to work, right? Anybody in any enterprise could basically start off with a free tool, following the methodology and the same systematic approach. And as tools so far, they all have their benefits and drawbacks. But it's possible. And in this case, what I really liked about Protégé is that they really have the clear distinction, for example, following basic formal ontology, where you go from a class and class of classes into an instantiation of a class, which is very clearly clarified. And then, of course, it could be complemented by another tool, like a graph database, show other dependencies or more dependency if you would like to. But this is what we discovered so far. And this is just then one example of how you could use URMSM if you're interested to keep track of your system engineering processes in an organized manner. So that's the last slide for me.